In section 1.4, we are measuring and classifying angles. We're talking about naming angles, measuring angles, and some types of angles in this section. So what is an angle, first of all? An angle is formed by two rays. Remember that a ray has one endpoint and goes on forever in one direction. So I have two rays creating this angle. Those rays are the sides of the angle. The rays have to share an endpoint, and this is like the most important point of the angle. This is the vertex of the angle. I'll label it V, so we're familiar. That is the vertex of my angle, again formed by two rays that go on forever. To name an angle, you can always name an angle with three letters. The vertex letter has to be at the center whenever you name with three letters. The vertex letter, again, is the most important part of that angle, so the vertex has to be at the center, which means in this case I need to put a point out on each side of the ray, each side of the angle, on each ray. So let's put point A there and point G here. So I can name this angle with three letters, and you just use like a mini angle as the symbol. So this is angle A, V, G. Again, with three letters, vertex letter V had to be in the center no matter what. You could name it the other direction as long as the vertex letter V is in the middle and do G first on this ray, then V vertex letter out through A. And I guess the easiest way to name an angle, if possible, is you can use just the vertex letter, but only if there is one possible angle. In this picture, there's only one angle I can talk about, and so in this case, I could just say this is angle V. Remember, you do need that angle symbol, and I can say this is angle V, again, using the vertex letter to name it. So what do I mean if there's only one possible angle? In this first example, there's more than one possible angle at the vertex, and if I asked you what letter here is a vertex of every angle, you better say letter N, or point N is a vertex of every angle. The problem is, if you just said, I'm talking about angle N, you'd say, well, I don't really know where you're looking because there's more than one angle here. So in this case, you can't do that. You can't just say angle N. There's more than one angle in the picture. And in this example, I want to name the three angles in the diagram. So hopefully you're looking at it and actually seeing three different angles here. If I want to talk about the angle from this ray to this ray, I could talk about angle, start at M, vertex letter has to be in the middle, which is N, and then go out through that side with the ray of O. So angle M, N, O. Or again, angle O, N, M. You can always change the order you named it, but N has to be in the middle. There's also an angle I could talk about over here. Now I'm going to do two sort of arcs through this. We're going to talk about the importance of that in a little bit. But if I want to talk about this angle, I could talk about angle, maybe I could name it O-N, vertex in the middle, P. Or of course I could change that and do P-N-O for the angle name, as long as N is the vertex letter is in the middle. And finally, can you see the last angle we can talk about in this picture? What if we talk about the entire angle? Which would be angle. I could start with M, that side, that ray, go to vertex N and out through ray P, angle M-N-P, or P-N-L. So actually three angles I could talk about here. Again, you can't just say angle N. The vertex letter is not sufficient here because there's more than one angle you could talk about. Protractor postulate. Remember, postulates are things we accept without proof. I just have P3 because it's postulate number 3 in this chapter. Again, these numbers don't matter. It's just the organization. But protractor postulate says every angle has a measure between 0 degrees and 180 degrees. 180 degrees is probably one of the more common angle measures that we use because it is a straight line. If you talk about doing like a trick on a wakeboard or snowboard or skateboard, a 180 would be facing one direction and then changing and facing the other direction because you're doing half a circle basically. 0 would be really no measure, but if you notice I can take this, if it lets me, I can take this and I'll apparently just move the ray I'm trying. Here we go. I keep going and I increase my angle measure if this is that second ray. And if I move this to correspond with the ray that I already put in place, and I want to see what is the angle measure of this angle, I'm at 135 degrees. Notice you have to be careful and decide what the size is of the angle that you're using, because you obviously have two numbers. Like, do I pick 45? Is it between 40 and 50, or between 130, 140, and 135? Well, the fact that I did go past 90 degrees, I'm now using, obtuse angle measures. So be careful with which number you're actually picking when you use a protractor. And to identify types of angles here, you're familiar with these classifying angles as acute, right, obtuse, or straight. An acute angle, there's an example of an acute angle, and what is its measure? And hopefully you're all thinking it measures less than 90 degrees. And actually, technically, if you think about it, it has to be more than 0. So it would be 0 is less than the measure of angle A, we'll call it, which is less than 90 degrees. So it has to be between 0 and 90 degrees. What is the definition of a right angle? Well, I'll draw an example of a right angle. Oh, by the way, an important thing about right angles. To show that this is for sure a right angle, you put a square in the corner like that, or a little box in the corner. So now this is definitely a right angle because I put this symbol. So a right angle measures exactly 90 degrees. What about an obtuse angle? I'll put an example of that. An obtuse angle measures what? You should be thinking more than 90 but less than 180. Whoops. So it's more than a right angle, it's more than 90 degrees, but it is less than 180 degrees, between 90 and 180. So if I wrote that out, I would say that 90 degrees is smaller than the measure of angle A. That's not an A. But that also has to be smaller than 180 degrees. And finally, what is a straight angle? A straight angle is literally a straight line, and it measures what? It measures 180 degrees. Okay, so examples of classifying angles: acute, right, obtuse, or straight, something you have used in the past. Let's do this for an example. Use a diagram to find the measure of each angle and classify, meaning tell whether it's acute, right, obtuse, or straight. Be careful with the naming, and make sure you're looking at the correct angle. Also notice this little M in front, and I did this back here. M means measure of, and you notice I have the angle symbol in front of all these. So I want the measure of angle DEC. Start at D, go to vertex E, which E is going to probably, well, it has to be the vertex of all of these, and go out through C. So from D to E, out through C. What is the measure of that angle? What kind of angle is that? I notice it's going right through 90 degrees. The measure of angle DEC is 90 degrees. What kind of angle is that? Well, it's a right angle then. Okay. Next example, what's the measure of angle DEA? Start at D, go to vertex E, go out through A. Start at D, go to vertex E, go out through A. Well, I just did a straight line, which I know measures 180 degrees, and this is a straight angle. What about the measure of angle AEB? Start at A, go to vertex E, out through B. Start at A, vertex E, out through B. A to E to B. You know what? To decide whether I'm picking 60 or 120 here, I gotta decide whether it's acute or obtuse. This definitely, from A to B, is not going past 90. It is acute. It's less than 90 degrees, and I'm going to pick 60 as the degree measure. What about the measure of angle CEB? Oh, interesting. I'm starting at C, going to the vertex at E, and going out through B. So notice for this one, I'm really going between here and here. So I definitely notice that it's acute. It's way less than 90 degrees. How many degrees is it? Well, this went from 60 to 90 or 90 to 120, and you think about how many degrees are in between. And we're looking at 30 degrees there. And finally, what's the measure of angle DEB? Start at D, go to E, out through B. This time, since I'm starting at D and going out through B, I'm going more than 90 to end up here. So I'm going to pick the obtuse number, more than 90, which is 120 degrees in this case, from D to E to B. So using protractors, talking about types of angles there. And the really important thing we're talking about today is angle addition postulate. Now we talked about segment addition postulate in a prior section. Angle addition postulate, just as important and very similar. With segment addition, we are adding segments together to get a larger segment. Here we're adding angles together to get a larger angle. I want to use what this says to kind of draw on the picture. If P, meaning point P, is in the interior or the inside of angle RST. Well, I'm going to stop there and let's label the picture accordingly. Point P is in the interior of angle RST. That means point P is here because it's somewhere inside this larger angle, which is angle RST. I can put R here, or here I guess, as long as S is the vertex because it's in the middle, and T would be out on the other way. Well, here's what this says. It says the measure of angle RST, that is the entire angle, is equal to the measure of angle RSP, which is right here, plus the measure of angle PST. Oh, okay, so if I add the measure of this angle to this one, I would get the entire angle measure. And that should make sense. If we have one angle that has a ray going through it, dividing it into two smaller angles, we should be able to add those two parts to get the full thing. That's what we're using when we use angle addition postulate. Let's do an example. Given that the measure, remember that means measure, of angle XYZ is 72 degrees. XYZ is 72 degrees. That means this entire angle measure here, XYZ, is 72 degrees, the whole thing. Find X. Oh, okay, notice this angle XYW is 3x plus 6, and this angle WYZ is 2x minus 9. I'm going to find X, and then I'm going to find the measure of each of these smaller angles. Well, if 72 is the entire angle measure XYZ, what can I do with these two parts, these two smaller angles that make up this larger one? We just talked with angle addition that you can add two smaller angles together to get the full angle measure. Oh no. That's what angle addition gives us. Sorry about that. So let's add these two angle measures, the 3x plus 6. I'm going to add that to 2x minus 9. And I know that together those angles have a measure of 72 degrees. There's a geometry portion. Let's do some algebra. Combine like terms. 3x and 2x is 5x. 6 and negative 9 is negative 3. And that equals 72. Let's add 3 to both sides. 5x equals 75. X equals 15. Alright, I've found X. And now I'm supposed to find the measure of angle XYW and the measure of angle ZYW. Now XYW is 3x plus 6, so I'm doing 3 times 15, 45 plus 6, which is 51 degrees. Measure of angle ZYW is 2x minus 9, so I'm doing 2 times 15, which is 30. 30 minus 9, 21 degrees. Now let me check, does 51 and 21 add together to give me 72? Yes, it does. Looks good. So angle addition. We're also talking about congruent angles. Now remember that congruent is our geometry term for the same or the equal or same or equal. So congruent angles have the same measure. Remember that we say angles themselves are congruent. So if angle A was congruent, using that symbol, to angle B, it would also mean that the measure of angle A was equal to the measure of angle B. So just like with line segments, there's a distinction here. When you talk about the measure, you're talking about the numbers, and the numbers are equal. When you're talking about the angles themselves, you're talking about the physical geometric object, and those things are congruent. So I want to do two angles up here. This will be angle A, and then so that I know the angles are congruent, I'm just going to copy and paste. And this will be angle B. I want to show you something real quick. Does this change the angle? Rotating? You should be thinking, no, the angle's still exactly the same. I could still get it back to normal, and yeah, it matches up. How about this? Basically, I made the rays longer and not rotate. Are the angles still the same measure? Well, actually, yeah, they are. It wouldn't matter how far out I drew those rays or how long. Again, a ray goes on forever, so that part wouldn't change it. It's just a matter of the angle size, I guess the spread between the two rays being the same. So if I put B at this vertex, you could say angle A is congruent to angle B. How come I can only do one letter and name with only one letter for these angles? Well, because there's only one angle in each. Alright. Last thing about this, how do I mark the angles congruent? We could mark line segments congruent, so there's got to be a way to mark and show with symbols that angles are congruent, and there is. You just put the same number of arcs in those angles. So if I put one arc like this in angle A and one arc in angle B, these angles are congruent. They have the same number of arcs. If I did two arcs in angle A and one here, no longer congruent. But now if I do two arcs in both, congruent again. So just like with those tick marks, you can do different numbers, but if they have the same number of arcs for angles, then they are congruent. Again, angles congruent, measures are equal. Alright, let's use what we know about symbols and marking for congruent angles to name some here. We have a pentagon, 5 sides. Can you name some congruent angles? Well, I see that these angles have one arc each. And I could name with one letter, since this is angle K and there's no other angle at vertex K. And I could say that angle K is congruent to, because I'm talking about the angle itself, not the measure, is congruent to what angle? Angle M. Because they both had one arc. You also notice there's two angles in this picture that have two arcs. Angle O and angle N. So I would say that angle O is congruent to angle N. Again, congruent angles because they have the same number of arcs. I can name with one letter since those are the only angles at those vertices. Another term for today, angle bisector. What does that word bisector mean? We talked about it for a few days now. Bisector means you're cutting, right? Like dissecting, but you're cutting into two parts that are congruent. So an angle bisector divides an angle into two congruent angles. Two smaller congruent angles. So let's get an angle out here. Alright, and let's, I want to put an array that looks like an angle bisector. Does this look like an angle bisector? I don't think so. It doesn't look like it's in the middle. Where should I go? How about right about here? I would say that looks close to an angle bisector. Maybe I should be going slightly more this way. Okay. Now it's an angle bisector if it divides this larger angle into two congruent angles. Well, how do I indicate that these two angles are congruent? We just talked about what you do to show angles are congruent. You put the same number of arcs in them. Okay, something to watch out for here though. If I just do an arc like this and an arc like this, it's really hard to tell whether I was doing one big arc or two smaller. So I want you, every time that you're going to mark two angles congruent that are next to each other, you need to offset them a little bit. If I put this arc here, maybe make this one a little further out. Now I can tell, oh look, yeah, there's two angles being marked congruent because they're separated here. I know that I'm saying this angle is congruent to this one. So an angle bisector, in this case, this ray is the angle bisector. It's the ray that cut an angle in half. It did the bisecting. And we cut into two congruent angles because I know that these are congruent because they're marked. So example of this, if ray, I know it's a ray because it has just the one arrow, if ray MN cuts in half. Ray MN cut in half angle PMQ. PMQ. So this ray cut angle PMQ in half. Ooh, what does that mean? That means I have two congruent angles. That means this angle here is congruent to, so I'll put the same number of arcs, this angle here. Let's see. And the measure of angle PMQ is 122 degrees. Now angle PMQ is the entire thing, so I'll do 2 arcs since I already did 1. And that's 122 degrees. If that's true, I want to find the measure of angle PMN. PMN is just this angle here. Now, if this MN bisected that angle, we cut it in half. These two are congruent. So really, I'm just doing 122 divided by 2. Each of these congruent angles, because of the bisecting then, would be half of that 122. So measure of angle PMN is 61 degrees. Each of these would be 61, giving me a total of 122 because it was bisected. And one more example. Using everything we talked about today, whether we're talking about straight angles being 180 degrees, for instance, any straight line here, this would be 180 degrees total. I have a 50-degree angle here, and we have a straight line. You should be able to find this angle measure. Same idea here, we have a straight angle of 180, but I have a 50-degree angle here and an unknown. Now, using angle addition, we know that adding these two angles gives me 180 because it's a straight angle or straight line. I want you to figure out every angle in this picture. We notice we have a congruent angle mark here, here, and here. Once you find this angle, these will be the same. Ooh, you should know what this mark means, the angle measure there. This is kind of your homework off the notes for today. Bring this to class tomorrow, we'll discuss it. So talking today about types of angles, measuring angles, congruent angles, and bisecting angles.